Hey everybody, good morning, afternoon, evening, depending on where you're joining us from. My name is Mustafa and I'm the co-founder and CEO here at Automata. And I'm really excited for you to join us today at our live launch event from our offices here in Boston and London. Today, we're going to be introducing the new generation of our LINQ products, our lab automation platform that gives you unmatched power and simplicity in your lab. Now, we started building LINQ around 3 years ago because we really believe that lab automation is two things. One, a really important tool in the future of your lab, and two, a technology that's incredibly difficult to adopt. Think about it. How many times have you found yourself thinking, it's got to be easier than this when you're deploying, programming, or running your automation? That feeling is why we've built LINQ. Not just to build another product, but to build a platform that truly simplifies lab automation and gives you the power to change the way you work in your lab. Over the next 40 minutes, we're going to be hearing from the creators of LINQ, who are going to walk us through a series of demos that show you the platform, its features, and what we believe truly makes them unique. But before all of that, I want to pull in London and introduce Nick, our VP of Product and Strategy here at Automata. Nick and I have been working together over the last 6 years, and this really feels like a moment we've been working towards for a very long time now.
Yeah, it really does. Thanks, Mustafa. I can't wait to show everyone what we've been building.
Yeah, same. Now, Nick, you and I have sat through countless product meetings over the last few years, centered around the same 3 questions that guide the development of LINQ. 1, does this support the full spectrum of automation users, from novices to experts? 2, are we really building an open platform that allows our users to build around it and not be boxed into it? And 3, are we building for scale? Especially that the majority of the labs we work for are going way beyond deploying single work zones. Now, as promised, showing is always going to be better than telling. So I'm going to hand over back to Nick in London, who's going to lead us through a series of demos designed to show how those principles are reflected in the new generation of LINQ. Nick, over to you.
Thanks, Mustafa. Okay, yeah, and I think the best place to start with this is on that first point that we talked about around supporting everyone. For so long, there's been this ongoing debate within the automation community about what's the best way to program automation. Is it through code, or is it through low code or no code solutions? And today, we want to put an end to that debate because we're going to give LINQ users both a node-based workflow builder for simplicity and speed, but also a powerful Python developer toolkit for more customization and more control. Like you said, though, this should be about showing rather than telling, and there's no one better to do that than 2 of the product managers who really led and were instrumental in the development of LINQ Cloud. So it's with great pleasure that I'm going to introduce Russ here in London and Luke over there in Boston with you, Mustafa.
Great, thanks Nick. We're going to dive into showing you some of the really cool new stuff that we've been building. But I think it'd be remiss of us to not go through some of the experiences that myself and Luke have had by way of introduction. So I've been working in life science automation for most of my career. I consider myself to be really close to an automation specialist. I care deeply about the science and the outcomes, and I've got a really good understanding about what my automation can do. But so often there's a huge barrier to entry to getting up to speed with programming these systems, even to get something simple going. And then if I want to do anything more complex, it requires a coding skill set that, quite frankly, I just don't have.
And I happen to come from the coding world with a more Silicon Valley background. And it's been really fun getting into lab automation, being able to play with all this awesome hardware. But I was honestly surprised and a little bit shocked at how difficult the developer experience could be, coming from a world of such a high focus on good cloud tooling, good developer tooling. It's been quite the contrast.
Yeah, and we've really tried to think about this dichotomy of simplicity versus power that's really required to make all of this amazing hardware sing and dance as we go through development of our digital platform. So with that in mind, I want to jump straight in and share with you some of the views on simplicity that we have and speed. And I'm going to demo to you our new Canvas workflow builder. I think it's worth setting a challenge here. I reckon I can build a workflow in maybe just 2 minutes. Obviously, I'm going to pick something quite simple. I'm going to take a plate, dispense some liquid into it, incubate it for 10 minutes, and then put it into a reader. So a basic reader-feeder experiment. But I want to show you how quickly we can go from nothing to something that is runnable. Luke, could you maybe hold me accountable for this as I do this and start a timer? And I am so confident on how simple this tool is, I'm not really going to get any kind of intro into how this is going to work. I'm just going to do it and voice it over.
All right, I got a timer going. Ready? And you're on the clock.
Nice, let's go. So here you can see the blank canvas that I'm going to start with. I've just called this a dispense and read method. And I am going to first of all add in a plate. Maybe I'll give that a name. I'll call it my assay plate just to help traceability through the workflow. And what did I say I was going to do? I was going to dispense into that. So I'm going to go into my task area and choose from all the tasks that are available on this particular work cell, my dispense task. I'm quite happy to do that with my multi-drop that I have. I need to tell it that it's going to take around about 2 minutes, and perhaps again, just for readability, I might give this a name and then specify the protocol that we are going to use from the device itself. After I've dispensed that liquid, I said I was going to incubate. So I'm now going to incubate step in. I'm going to do that incubation step in a Lyconic incubator. I'm going to do that for 10 minutes. And now I want to give it some freedom. So I need to specify a slot range here. So slots are all the positions within the incubator. I'm just going to say 1 to 20. So it allows me to maybe do up to 20 plates when I come into batching this in a moment. 2 more steps and then we're done. I was then going to read that plate. So I can read that on my Synergy plate reader. Again, we're just going to say that takes maybe 3 minutes. If I was running this live, I'd need to add in a protocol there as well. And then finally, the last thing I have to do is tell it where I'm going to end that labware. If I was just finishing everything on the plate reader, it's only got 1 plate carrier, so I'm going to have problems running multiple plates through this system. So I'm just going to, in this case, because I'm lazy, I am going to dispense things. Dispose of things. How am I doing for time, Luke? That felt pretty quick.
You're just under 2 minutes. Let's do the home
maybe
stretch.
I'm going to run over here. I thought I could go straight into planning this now, but it looks like I have forgotten to do something, which is definitely going to push me over the 2 minutes. I'm just going to go to my assay plate, which obviously has this missing starting position if I'd looked more closely at that. I just need to tell it that's going to start in a particular device. And again, I'm just going to tell it that you can have a number of plates in there. So I've got the freedom to now plan this for multiple iterations. So now hopefully it says, yep, I haven't made a plan before and I'm free to go. I can hit save and plan and I can do this for maybe the 20 plates that I set the maximum capacity for. And pretty much instantaneously I get back a plan. I have done no optimization on this, but you can see every plate is being treated pretty evenly throughout the workflow. How did we do, Luke? That was definitely over 2 minutes, right?
Yeah, I clocked you at 240, but pretty good for dealing with an error and being on camera.
Yeah, I'll take that. I'll take that. Now, obviously that was super simple, but it does show you how quickly you can go from pretty much a blank workspace into being able to build a workflow that I could with a couple of extra settings, I could run that on one of the work cells here in a couple of minutes time. Before I go into the next phase, and I'm not going to go into every single detail we've put into the canvas, I just want to show you a couple of the components that we put in place to start enabling you to build more powerful workflows. So not everything in a graphical user interface has to be simple, right? Let's say that I want to do something else really common in workflow building. So adding in time constraints is one of the most common things we get faced with. In this case, I want to say from the end of this dispense phase to the start of the read phase is going to take no more than, I don't know, let's say 15 minutes. As you can see, as I'm hovering around the canvas, I get these extra little sockets on the side. These represent the start and the end of tasks. And I can just pick up a line from the end of that dispense and drag it onto the start of that read step and add in my time, and I've now set a time constraint. Now, it's worth speaking really briefly here about how good our planning engine is at dealing with things like incubations and time constraints. It will adhere to these super tightly. So if I've now said that should be a maximum of 15 minutes and the incubate was 10 minutes, that is going to be the constraints that it applies when it's doing planning. And if it can't find something that's going to work, it's going to come back and tell you so. And it carries those constraints right through to runtime. So our planning engine's got this amazing ability to really stick to those time constraints. So moving on to something else a little bit different from everything we talked about so far, I want to show you how we add in things that aren't necessarily related to the physical movement of labware, which is what we talked about so far. I've taken a plate and I've done a bunch of stuff to it. You can see on my read step, I've got this little thing called a result with a slightly different looking socket below it. This is data that's being generated by that plate reader. And as well as building in these physical flows of labware through the system, I can also start layering in data flows through the system. Now in this demo environment, I've got very limited data processing steps available to me, but let's just say, for example, I wanted to take that result and convert that into a different file format, ready for export to whatever my source of truth might be, my LIMS or my ELN, for example. You can see that how easy it is to pipe that data together, and I could string a bunch of these together to start building out data flows that go through the workflow, and even pipe that data back into tasks as and when required, for example, for generating things like hit lists. That is pretty much everything I want to show you in the canvas today. I've talked you through how to build a really simple workflow. I've shown you some of the things where we can start bringing a bit more complexity and power into the canvas. Having done all of that, it makes quite a lot more sense for us to now actually maybe run a system and show you what it looks like to actually interact with our benches. But we don't want to make our lives easy. Let's do something a little bit more complicated, and let's also bring a bit of that developer experience we've started alluding to into the conversation. I think what we'll try is, why don't we run the system in Boston, and you start it from the developer experience, Luke, and then I will show people what it looks like to monitor that from on the other side of the Atlantic over in London. But I need your help for that. I can't do that on my own.
So it's a good idea, Russ. I think that'll tease some of the stuff we have coming up next with the developer experience. Okay, so share my screen here and we can see my developer environment. I'm not going to go too into detail just yet on this, but for now, let's use the LINQ command line interface to get this work cell started. So I'll just type in LINQ work cell start, and then I've got a GUID copy pasted here for the identity of this work cell, and we'll hit go. All right, we start. We've got the beeps. Awesome.
See stuff moving.
Yeah, we're getting going. Plates are starting to move. All right, so as this goes, Russ, you know, this is probably a good opportunity for you to show off, just like you were talking about, that run experience, that what you can see from London about the system. After all, we're running a demo workflow here where there's just a lot of transport moves. Yeah, what do you see?
Yeah, so let's have a look at my screen. So what's kind of fun is as you were setting that up, I can see everything initializing, I can see everything getting going. So we can see, just to walk people through what I'm looking at, in the graphical user interface, I can see all of my run control information. So if I wanted to be cheeky at the moment, I could pause and stop that run remotely. I also get this Gantt chart view of all the different things that are going on. As Luke said, this is mostly a bunch of transports on a demo system. Most scientific workflows are actually surprisingly boring to sit and watch. So we just have loads of different transportations going on. The other thing that we get represented here is any error state information as we're going along. So what may be good to do is generate an error if we don't think that's too crazy.
That's a good idea. You know, I think let's have a CEO does what a CEO does best and bump into a robot while it's moving here. I don't know. Knock into something. I guess. Yeah, yeah. All right, perfect. Okay, and you know what? Actually, before we go to you, Russ, I'll show what it looks like from the developer experience. So, Mustafa just bumped into that robot, and I'll type in here LINQ work cell error get latest, and then the work cell ID. Look at that. All right, let's bump up that terminal. Automata transport failed. Please check the robot, remove any obstruction, and make sure the robot's safe to operate. Well, I have removed the CEO obstruction, and now the robot is indeed safe to operate. And you can see I've got different actions available to me. But Russ also has those actions available via the cloud interface. So how about you push the button from London?
Yeah, I can get that going from here. So as you can now see in the run manager, we can also see that same error as Luke described. There is a transport failure because of an obstruction being in the way that we have now removed. So I should be able to hit try again, and the system will start running again.
Nice.
Off we go.
That was like instant over here.
Yeah, very cool. Absolutely seamless error creation across the pond there. I think we're going to kind of wrap up this section and move on to something a little bit more in depth in a moment. I just want to go back and highlight some of the things we just covered. So we showed you how easy it is to go from nothing to building a really simple workflow, and then went into our run experience and showed you how we could run that system and started to show you a little bit of that interoperability between our developer experience and our visual management tooling. So with that, I'll hand you back to Nick.
Thanks, Ross. Yeah, unlucky on the 2 minutes, close though. And Luke, I'm going to hold on to you for a sec because I think we've shown a bit of the developer experience, but as we look at our second key principle that we built around openness, I want us to dig a bit deeper into it. Personally, I believe that the best products are those that let people build around them. And it's something that we've heard from the automation community that they're desperate for. And we know that automation cannot live in isolation. Work cells have to be deeply embedded, deeply integrated into the digital ecosystems around them. And that's why today we are launching the most complete and comprehensive developer toolkit in work cell automation. And Luke, maybe you can tell everyone a bit more about the specifics of what I mean when I'm saying that.
Yeah, absolutely. We've been teasing about it and talking about it here so far, but I'll get really specific now. I'm really proud to say everything we've been showing so far, from the run manager to the workflow canvas, has been something that you can also control via the API. This is an API-first platform, and we've also deployed a Python SDK that wraps that API, creating a very seamless, convenient developer experience. That means you can build whatever you want on top of it. You have full control of the run experience of the work cell. You have full control of the workflows you run on the work cell, and full control of your data integrations and upstream and downstream systems. And you don't have to take my word for it. After this call, we're going to publish all the documentation, and you can dig in yourself, see exactly what you want to do and how you might want to configure your system. I'm really proud of what we've done, and I think you're going to find something exciting for whatever use case you have in mind.
Yeah, it's exciting. It's exciting to think what people are going to build with it. I definitely can't wait to see the uptake and what happens post that point. So, Luke, I think the demos have been going pretty well. So I'm gonna ask you. I know you've prepared another one, and what we really want to do here is show everyone and give everyone a taste of the kind of power that this new developer experience unlocks. So back over to you.
Awesome. So, yeah, I was thinking about what I could demo, and I wanted to show a use case that kind of historically has been rather difficult in lab automation, but I really feel like it shouldn't be. So I made something quick last night to show this. And this scientific use case here on this diagram I'm showing should look familiar to a lot of folks here. At the start, we have cells incubating somewhere on the work cell, and then we want to take those cells out and image them. We're going to take that image, and then send that to an external system for some machine learning analysis. From there, we might want to put it back in to go incubate some more, or perhaps even bin it if we find contamination or something, or proceed on with a workflow with some media exchange. But anyway, that's what I want to show. And the work cell here is busy right now, and I don't have any virtual cells, so I've actually created a little simulation to also showcase configuring code live on the work cell. So you can see here, I have these tasks. I'm not going to dive fully into the code. You can see my whole workflow is only 82 lines of code. But I've configured a task here, and this is a node just like you saw with the visual canvas, but listed out here in a declarative Pythonic language. You can see actually I generate a 12 by 12 matrix simulating luminance data. Basically, here's the actual Lua code. We have inline Lua scripting for all the NeoVim fans, but of course we also have Python available too that can run directly on the work cell. And then we take that and send it to an external endpoint. And in fact, I'll stop walking through it and I will just demo this workflow right now. I did this in my own personal AWS just to demonstrate how you can connect anywhere. So let me actually connect to that Lambda first. AWS logs tail / AWS Lambda Automata demo, and we'll follow those logs. All right. And then let me grab my virtual work cell, different GUID than the one for this one, and we'll go LINQ work cell start, and kick that off. And this command line interface also wraps the Python. It's just another convenient way you can interact with the system. You can do the same thing with a REST call or a Python call. All right, fired it off. We got the workflow. I'm going to pull this up. It's a quick workflow. It's all happening in code virtually. So I'll pull up my diagram here to walk us through it as we wait for the Lambda logs to come through. Really what we're waiting for is CloudWatch. There it is. All right. That's a lot of stuff. Let me walk through it really quick. So here's what we can see first. We received some data from the work cell. What did we get? I made a little ASCII visualization here of the virtual cells we've created and we want to classify. So those are created directly at runtime on the work cell. In real life, that would be a cell image. And then, of course, my Lambda here. Now we're on this step. We've sent this data off to my Lambda. We're running a machine learning. We've classified it as a lighter image. I created two classifications, light and dark. You know, if you want to hear more about how actual cells work, ask Russ. He's the scientist. And then I've taken that classification, which in this case looks like it was the light classification, and I've sent that back to the work cell and then had the work cell conditionally execute a different plan and then proceed with the light fork of the workflow. I won't belabor the point here, but I hope that gets your imagination going for what you could build and just some of the tools that are available in, again, what are public docs that you can go view. No logins, no reach out for contact. Finish the call and then go check out the docs. All right, back to you, Nick.
Yeah. Nice. Yeah, I think it's such a good application to show so many elements of what we talked about, and ultimately it's crazy to see how much simpler closed loop applications can be now. Okay, well, with that, we're going to move on to our third and final principle that we built this new generation of LINQ around, and that's built for scale. What I mean by scale is the deployment of multiple work cells, often with multiple teams working across them, and sometimes across multiple different sites. Now, it's that kind of scale that we built LINQ for from the get-go. It's the only platform that's been built for that kind of scale from the get-go. It's why we built LINQ as a cloud-native platform, because of how much simpler it makes collaboration and management all across multiple work cells from anywhere at any time. And Russ and Luke showed a bit of that earlier. But it's also why we have built and focused around a common hardware platform, LINQ Bench, because that streamlines everything from design through to deployment and through to the ongoing support that our customers experience. And so with that, it's with huge pride and huge excitement that I introduce to you the new generation of our award-winning product, LINQ Bench.
Hi everyone, my name's Dan and I led the design of our new LINQ Bench.
And I'm Alice, and I'm a field application scientist.
So we've created an entirely new bench system driven by ultra configurability. The new bench is more open, more adaptable and more accessible than ever before. We're allowing for more automation to happen in less space while never losing focus on the scientist itself.
I've spent a lot of my career in the lab, and I know all too well the pain of interacting and accessing instruments. And that's not just because of my height. So one of the first things I noticed about this bench is that I'm able to stand directly at it, and the robot is still just here.
Yes, one of the first things we wanted to do when we started this project was get the robot and its rail inside the bench footprint. This allows the user full access to the system and gets them closer to it, while keeping the automation itself as minimally intrusive as possible. But we didn't stop there with our usability improvements. Shall we light this up and take a look at some more?
Let's do it.
So, as you can see, the lights have turned on. And this is probably my favorite feature of the bench, despite some of the other things we're going to talk about. This is the connection to the software and really shows that the bench and the system is alive. It communicates to the user what's going on. This is the system status. But also we've gone further. You saw that really cool swipe. It's fully addressable, fully dynamic. And this unlocks a whole new world of user feedback possibilities. So we can really enhance the user experience.
Looks pretty sci-fi too. I think I would have really loved to have worked in a lab with this, because what it means is you don't have to hunch over a computer screen to see the system state. You can be elsewhere getting on with another task, which makes life in the lab a lot easier. One thing that I really love about this is how accessible everything is. In the past, trying to access a piece of equipment to change a consumable might have meant you have to move another instrument out the way. It might have meant that you actually have to climb into the hardware. And that was often my job as one of the smaller people in the lab. But with this, you can see how you can reach in at the side, and you can also really reach into the bench. And if you still have an issue of accessibility, like with this slider, we have a solution for that. So what I'm able to do is I'm able to pull out this slider. I'm able to open it up, replace any consumables I need to, close it back up, and push it precisely back into the same position. What this means is that I don't need to reteach any waypoints, I don't need to do any instrument recalibrations, it will just work.
Yeah, so let's see if it is still working. We're going to start this moving now. So you see the lights have changed to blue. This is indicating it's now running in an automated mode, and the robot is moving to the plate that's on the peeler that Alice just moved. So with the accuracy, it will still pick this up uninhibited, and then it will move on about the rest of its workflow.
Yeah, it's a great relief to not have to worry about touching an instrument that's part of an automated workflow.
And talking of workflows, I'd like to update you on some of the other features we've made that allow us to precisely shape the benches to the needs of your instrument or your workflow. So you can see we have double, triple, and you can even quadruple stack these benches. There are over 800,000 possible combinations in terms of how this can be configured to suit your needs and fit what you need to do for your workflow. So should we take a look at some of those workflows?
Absolutely. I really love the stacking, especially that we can now stack multiple instruments that we couldn't stack at all before. What this means is that we're able to do more in less space. So in the example you see now, I created a double stacked extraction work cell. This uses 3 benches to integrate 4 high throughput extractors. We've never seen this done before with this piece of equipment. Previously, we would have needed a whole LINQ bench per extractor. So that would probably be around double the lab space required. But now we're able to increase the throughput without increasing the footprint. And that's mainly due to the use of vertical space.
And this is exactly what we wanted the new bench to achieve. And it's great to see how densely packed this looks. And another key aspect that we focused on a lot with the new bench was on weight reduction. How prohibitive or complex can weight be when it comes to designing a system?
Yeah, it can be a really big problem. So when we're designing a system like this, we really want to think about the weight allowance of the lab floor. And most of the allowance should be dedicated to instruments and not the benches. When I first started designing these systems, I was surprised at how quickly the system weight would become a blocker. And this is in part due to the more complex instruments being a lot heavier, and partly because a lot of the labs we work with are actually converted spaces, so they've got really low weight allowances on their floor.
And one of the first things we did was we changed from a steel construction with our previous bench to aluminium in this one. We've halved the weight of a single bench while almost doubling the actual load capacity of the bench itself. But we didn't stop there with our weight reduction. We've completely overhauled our sample transport system. And that's not only to reduce the size and the weight, but also to massively increase the speed and the throughput. So if we move over here, you can see on the top deck, we have our LINQ bridge. This is for back-to-back, point-to-point movement. Really good for setups like this. And it's also really good for side-to-side movements where you're trying to span a small space at high speed. And if you need to go longer and more higher distance, we have our maglev solution here. This is made of planar motors tiles, and this is for high speed throughput for multiple samples to multiple locations across your entire work cell. And that could be 2 benches, it could be 10 benches, it could even be beyond your work cell and more. Both of these solutions work around your instrument setup rather than dictate and drive it. So shall we have a look at what that means for some application?
So this is a cell line development system that I redesigned with the new benches. What I've been able to do is take away 3 benches, massively reducing the size and the weight of the system, while still maintaining the functionality and the throughput. The main reason I've been able to do this is using this new transport system. It doesn't require a whole bench surface, and therefore we have loads more space for instrument integration.
So if we can maintain throughput while reducing benches, how does it work if we want to scale throughput, and what does that look like?
Well, do you know, I've got another one for that.
That's convenient.
So this is a cell-based assay work cell, and we designed this with scale in mind. So this first system is just a 2-bench system that can run around 30 plates a day. This is already a great use of space. When we start to think about how we might scale this, we can add just 1 tool bench, and this can increase the throughput over 300 times. And this can be done without reconfiguration of the first system, making scaling less disruptive and easier.
Yeah, it's great to see how many different ways you're using the new benches and how creative you are with it, and the possibilities that's unlocking for your scientific workflows.
Yeah, since we've had our hands on it, it's unlocked a bunch of exciting possibilities for us. What it means is we can tailor to the needs of the workflow much better, and we can also think a lot more about shaping precisely to the physical space of the lab.
We're incredibly proud of what we've achieved with the new LINQ Bench. It's ultra configurable with almost unlimited possibilities. We've supercharged our sample transport while maintaining the freedom for your instruments. We've doubled the instrument capacity within a single bench footprint, and we've done all of that while making the bench more open, more accessible, and much more user-friendly throughout all of the touch points.
And with that, let's go back to Mustafa in Boston.
Thanks, Alice. Thanks, everyone. That was really great to watch from the sidelines. And I'm really excited about all the work we've shown today. I also know that that was just the tip of the iceberg because there's a ton of functionality we couldn't show today because of the time. On that note, if you want a personalized walkthrough or demo from our team, get in touch on our website at automata.tech. Also, if you're going to be at SLAS in the coming week, feel free to stop by our booth, book some time with our team on our website again to see the platform in real life. Finally, we have a bunch of webinars coming up soon to dive deeper into the platform, so watch this space. Now, before we wrap up, I really want to take this chance to thank the incredible team here at Automata for all the hard work building LINQ. It hasn't been easy. There's been breakthroughs, challenges, and countless late nights. But we really believe it's been worth it, and we can't wait to see what you do with LINQ. On that note, thank you for joining us in Boston, in London, wherever you are, and see you very soon. Thank you.